In the desert, the AI boom does not look like a chatbot. It looks like concrete shells, power lines, cooling pipes, and rows of servers waiting for chips. China is reportedly preparing a 5-year plan worth about 200 trillion yuan, or $295 billion, to build a national AI data center grid. The goal is more AI compute, spread across the country, linked through state-backed networks, and built mostly with Chinese technology. The plan has not been published as a final official document, but it fits a system China has already been building: East data, West computing. Crowded eastern cities create the demand, while heavy computing work is pushed toward western regions with more land, energy, and cooling advantages. The older system was about moving data and compute across geography. The new reported plan is more focused on AI. It would connect scattered data centers into a coordinated compute network, with state telecoms such as China Mobile and China Telecom running much of the plumbing. A data center is not useful just because the building is finished. It needs accelerators, power, cooling, network capacity, and software that can schedule work across all those machines. China also wants the core technology inside that system to be domestic. Reporting on the draft plan says the target is at least 80% homegrown technology, including AI chips. That points towards Huawei Ascend systems and other Chinese accelerator suppliers. The pressure did not start with this reported plan. Reuters previously reported that state-funded Chinese data center projects were being told to use domestic AI chips, and some early-stage projects were told to remove foreign chips or cancel foreign chip purchases. Export controls are a major reason. The United States has tried to keep the most advanced NVIDIA chips out of China. China has responded by pushing domestic silicon, domestic clusters, and infrastructure that can keep scaling when foreign supply gets tighter. Replacing NVIDIA at national scale is not a simple swap. Advanced AI chips need memory, packaging, manufacturing capacity, networking, drivers, and developer software. A domestic cluster can be real and still trail on efficiency, availability, or ease of use. This is why telecom operators matter. China Mobile and China Telecom already build national networks, run critical infrastructure, and handle huge state-backed projects. In an AI grid, the hard work is routing, uptime, capacity planning, procurement, and keeping the machines fed with electricity. Power may become the hardest limit. Training and serving AI models turn electricity into heat, then spend more electricity removing that heat. The best chip strategy still fails if the grid, cooling system, and local water or land constraints cannot keep up. China's geography helps and complicates the plan. Western regions can offer cheaper land, renewable power, cooler air, and room for giant campuses. Eastern cities still need low-latency service for finance, factories, hospitals, and consumer apps. Moving compute west only works when the network is fast and reliable enough. The scale also needs context. $295 billion over 5 years is enormous. Bloomberg segment notes that United States hyperscalers are expected to spend more than that in a single year. So the contest is moving down the stack. Model demos still matter, but the bottleneck is becoming physical. Chips, factories, substations, fiber routes, cooling systems, and enough skilled operators to keep the clusters running. China's reported plan is a bet that compute can be organized like national infrastructure. If it works, Chinese companies and government agencies get more predictable access to AI capacity, even under export control pressure. If it struggles, the weak points will show up as chip shortages, idle buildings, power bottlenecks, or clusters that cost too much to run. The clearest takeaway is that AI competition is becoming visible. It is no longer only model names on a benchmark chart. It is the race to turn energy, silicon, land, telecom networks, and public finance into usable compute.